My discussion different properties of a complex number. First property is related to operation, addition operation. Addition operation, what are the property? First property is closure property. Closure property. Closure property. Closure property, what is closure property in complex number? Let Z1 and Z2 belongs to Z, then Z1 plus Z2 also belongs to Z. That is known as closure law or closure property. For example, suppose Z1 is equal to 5 plus 7i and Z2 is equal to 2 plus 9i, Z1 plus Z2 is equal to 7 plus 16i, which is belongs to Z. That is what? That is the property of closure property in case of addition. That is closure property. Then next property is commutative property. Next property is commutative property. What is commutative property? Just you see commutative property. Commutative property or commutative law. In case of commutative property, let Z1 and Z2 belongs to Z, then Z1 plus Z2 is equal to Z2 plus Z1 is also belongs to Z. That is what? Commutative property. For example, suppose Z1 is equal to 3i, Z2 is equal to 5i plus 5. 5i plus 5. Now we convert Z1 as a complex number 0 plus 3i. What about Z2 here? 5 plus 5i. Now Z1 plus Z2. Z1 plus Z2 is equal to 5 plus 15i. 5 plus 8i. 3 plus 5, that is 8i. Z2 plus Z1 is equal to what? Z2 plus Z1 is also 5 plus 8i. That is belongs to Z. That is also belongs to Z. Here we describe Z1 plus Z2 is equal to Z2 plus Z1 is belongs to Z. That is what? Commutative property, or that is what? Commutative law. That is what? Commutative laws in case of addition. This is one more property in a complex number. Again, another property by another law, that is associative law. What is associative law? What is associative law? Associative law. Associative law. Suppose or let Z1, Z2, Z3 belongs to Z. If Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3 is belongs to Z. What is that? That is what? Associative property. What is associative property? Z1 plus Z1 plus Z3 is equal to Z1 plus Z2 plus Z3. Let us start an example. Suppose Z1 is equal to 7i plus 7 plus 2i. Z2 is equal to 3 plus 9i. Z3 is equal to 0 plus 6i. Now we justify under the associative law. How? Z1 plus Z2 plus Z3, Z2 plus Z1 plus Z2 plus Z3, Z2 plus Z3. That means what is Z1 here? 7 plus 2i plus what is Z2? Z2 is equal to 3 plus 9y. Z3 is equal to what? 0 plus 6i. Then 3 plus 0 it is 3. 9 plus 6 is 15. That is what? 3 plus 15i. That means my addition real part to real part as well as imaginary part to imaginary part. That is why it is 3 plus 15i. Again, Z1 plus Z2, that is what? 7 plus 3, real part to real part to real part and imaginary part to imaginary part. That is why it is 10 plus 17i, which is belongs to where? Which is belongs to Z. Similarly, we also check that Z1 plus Z2 plus Z3. What is that? Z1 plus Z2, 7 plus 3, how much it is? 10 plus 2 plus 9, how much it is? 11i plus Z3. What is the value of a Z3? Z3 value is 0 plus 6i. That means it is what? It is what? It is 10 plus 10 plus 17i. That means Z1 plus Z2 plus Z3, which also belongs to Z. That means this part is equal to this part. For this, that means Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3, which is a what? This is a satisfying associative law. Which is satisfying associative law. That means the addition operation justify closure law, commutative law, as well as associative law. Then, after completion of associative, then identity law. Identity law, other way it is known as additive identity. Other way it is known as additive identity. Identity law. Suppose Z1, let Z1 is belongs to Z and 0 also belongs to Z. That means Z1 plus 0 is equal to 0 plus Z1 is also belongs to Z. Here 0 is treated as additive identity. Here 0 is treated as additive identity. For example, suppose Z1 is equal to what? 3 plus 5i. Z2 is equal to 0. Now we convert 0 as a complex number. 0 plus 0i. That means Z1 plus 0, which is equal to what? 3 plus 5i. 3 plus 5i. How? 3 plus 0, it is 3. 5 plus 0, it is 5. That is what? Z1 plus 0 is equal to 3 plus 5i. Similarly, 0 plus Zi is equal to what? 3 plus 5i. That means Z1 plus 0 is equal to Z1. 0 plus Z1 is equal to Z1. What is the role of 0? 0 is treated as additive identity. Both proper. That means additive identity as a property of addition. After that, then additive inverse. Here 0 is additive identity. Then additive inverse. What is additive inverse here? Additive inverse. Just you see, let Z1 belongs to Z and minus Z1 is also belongs to Z. If Z1 plus minus Z1 is also 0, this is what? Minus Z1 is the additive identity of Z1, or Z1 is the additive inverse of Z1. Similarly, minus Z1 is the Z1 is the additive inverse of minus Z1. That is why, just you see example. Suppose Z1 is equal to 3 plus 5i. Minus Z1 is equal to what? Minus of 3 plus 5i. That means minus 3 minus 5i. Now we proceed for Z1 plus minus Z1. What is that? Z1 is equal to what? 3 plus 5i minus plus minus 3 minus 5i. Minus 5i. Right or not? Minus 5i. What is the minus 5i? That means plus 3 minus 3 cancel, plus 5i minus 5i cancel. That means Z1 minus Z1 plus minus Z1 is equal to 0. Right or not? And that 0 also 0 plus 0i, which is what? Additive inverse. Which is what? Additive inverse. Which is what? Additive inverse. That means the addition operations justifying complex number as a closure property, justifying the law of commutative property, justifying the law of associative property, justifying the law of identity property, and justifying the law of additive inverse property. What is that? between the two complex number or more complex number. After completion of addition, then we again justifying the properties of multiplication. Justifying the property of a multiplication property, multiplication operation. In multiplication, similarly, I have a closure law. I have a closure law. What is that closure law? Just you see, let Z1 belongs to Z, Z2 belongs to Z, then Z1 into Z2 also belongs to Z. What is that law? That law is closure law. For example, Z1 is equal to 3 plus 5i, Z2 is equal to 2 plus 7i, Z1 into Z2 is equal to what? Just you see, 3 plus 5i into 2 plus 7i, right or not? So we can apply the product rule here. 3 into what? 3 into 2 plus 7i, again plus 5i into 2 plus 7i. How? You can multiply 3 into 2, it is 6, plus 3 into 7, that is 21i, plus 5i into 2, it is 10i, plus 5i into 7i, it is 35y square, right or not? So 6 plus 21y plus 10i, how much it is? Because both have the imaginary part, we make add 21 plus 10, it is 31i plus 35 into what is the value of I square? I square value is minus 1. That is why 6 plus 31y minus 35. Hence, what is that? Minus 6 minus 35, it is a real part. So minus 29 plus 31y, which belongs to Z or not? Yes, it is belongs to Z. That means if Z1 belongs to Z, Z2 belongs to Z, then Z1 into Z2 also belongs to Z. That is the law of closure property. As well as closure law in case of multiplication. Similarly, after completion of a closure law, then another law is commutative law. What is commutative law in case of a multiplication rule? Just you see, just let Z1 comma Z2 belongs to Z. If Z1 into Z2 is equal to Z2 into Z1 belongs to Z, then this law is what? This law is known as commutative law. This law is known as commutative law. This law is known as what? Commutative law. This law is known as commutative law. For example, suppose I have a example. Suppose I have a example. Z1 is equal to 3 plus 7i. Okay. Z2 is equal to 2 plus 1i. So what is the product of Z1 into Z2? Z1 into Z2 is equal to 3 plus 7i into 2 plus I or 1i, that means I. Then we can multiply 3. 3 into 2, it is 6 plus 3 into I, that is 3i. Plus 7 into 2, it is what? 14i, plus 7 into I, it is 7i square. So what is that? 6 plus 3 plus 14, 17i, plus 7 into I square means minus 1. What is the value? 6 plus 17i minus 7. 6 plus minus 7, how much it is? Minus 1 plus 17i. So Z1 into Z2 is equal to what? Z1 into Z2 is equal to minus 1 plus 17i. Similarly, what about Z2 and Z1? Similarly, Z2 and also Z1, Z2 into Z1 also, we can multiply 2 plus I into what? 3 plus 7i, 3 plus 7i. Then we can multiply 2 into 3, that is 6, plus 2 into 7, 14i, plus I into 3, 3i, plus I into 7, 7i square. So what is the value? 6 plus 17i plus 7i square as minus 1. How much it is? 6 plus 17i minus 7. Then after simplification, it is minus 1 plus 17i. That means Z1, Z2 into Z1 is equal to minus 1 plus 17i. That means Z1 into Z2 is equal to minus 1 plus 17i. Z2 into Z1 minus 1 plus 17i. That means both are belongs to Z. Both are belongs to Z. This result is equal to what? This result also. That is why Z1 into Z2 is equal to Z2 into Z1, which is the law of commutative law. Commutative law, and this is the properties of multiplication in a complex number. Clear it is? After completion of multiplication rule, then again another discussion as associative rule in case of multiplication. Associative rule in case of multiplication. What is that? In case of associative law, just you see associative law. Associative law. What is associative law? Just you see, suppose Z1, Z2 and Z3 belongs to Z. Here Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3 belongs to what? Z. If both sides are equal, then it is under the law of associative law. We take an example, please. Example. Let Z1 is equal to 3 plus 7i. Z2 is equal to 2 plus 9i. Z3 is equal to 1 plus 2i. Now we justify this rule. Z1 into, we can take the LHS part of this, LHS part. So what? Z1 into Z2 into Z3. That means what? Z1 into Z2 into Z3. That means 2 plus 9i into 1 plus 2i. So what is Z1? Z1 is equal to 3 plus 7i into 2 plus 9i into 1 plus 2i. You can multiply 2 into 1, it is 2, plus 2 into 4i, it is 4i, 9i into 1 plus 9i, plus 9i plus 2i, it is what? 18i square. Then you can simplify this one. You can simplify. This is what? 2 plus 9 plus 4i plus 9i, it is what? 13i plus 18i square as minus 1. So what is the value? 3 plus 7i into, what is that? That is minus 18. 2 means what? It is minus 16 plus 13i. Again you can multiply 3 into 16 minus 14 minus 48 plus 3 into 13, that is 39i plus 7 into minus 16, how much it is? That is what? 2, 7 into 37, 42, 4, 7, 7, 4 is 1, 1, 1, 2, minus 1, 1, 2, I, minus 1, 1, 2, I plus 1, 2, 9, 91 I square, 91 I square. How much it is? That means minus 18 plus 39i minus 112 I. 39i means what? It is 3. It is 3. It is what? 3, 10, 10, 3, 7. 7i minus 73i plus 19i minus 1. What is that? Again, minus 18 minus 91. What is that? What is that? That is what? 9, it is 13. 13 minus 139 minus 73i. That is what? That is the product of 3, Z1 into Z2 into Z3. Similarly, we also go for Z2 Z1 into Z2 into Z3, which also equal to 139 minus 73i. That means this part is equal to this part. Then it is justify associative law. Okay. In case of a properties of a complex number, we justify the multiplication rule. If we justify the multiplication rule is also justifying the law of closure law, commutative law, as well as associative law. Then another is multiplicative identity. What is multiplicative identity here? Just you see, in case of a multiplicative identity, suppose multiplicative identity Z1 into 1 is equal to 1 into Z1 is belongs to Z. That means this one is representing multiplicative identity. For example, suppose Z1 is equal to 3 plus 5i. What is 1? We can multiply 3 plus 7i into 1. 1 means what? 3 plus 7i into 1 plus 0i. You can multiply into 1. 3 into 1, 3 plus 7 into 1, 7i plus 0 plus 0, 0i plus 0, 0, 7i square. What is the value? 3 plus 7i plus 0 plus 0. That means 3 plus 7i. That means Z1 into 1 is equal to Z1. Then this one is represent as multiplicative identity, right or not? This Z1 is also multiplicative identity. Similarly, 1 into Z1 is also Z1. This one is otherwise known as multiplicative identity in a complex number. This is one more property in case of complex number. Then multiplicative inverse. What is multiplicative inverse? You see multiplicative inverse. Just you see. Suppose Z1, let Z1 into 1 by Z1 is belongs to Z. That is why Z1 into Z1 inverse is belongs to Z. That means Z1 into Z1 inverse is equal to 1. Here Z1 inverse of Z1 is known as multiplicative inverse. Z1 also multiplicative inverse of Z1 inverse. That is what multiplicative inverse. Now we can take example. Just you see, I have an example. Z1 is equal to 3 plus 5pi. Find multiplicative inverse of Z1. Just you see, Z1 into Z1 inverse is equal to 1. Now I want to find Z1 inverse. That means Z1 inverse is equal to what? 1 by Z1. 1 by Z1 means what? 1 by 3 plus 5y. Now I convert this is a rationalization form. What is rationalization form? So you can multiply conjugate part of the number. 3 plus 5y. Then what about the conjugate? 3 minus 5y. If we can multiply, then automatically we also divide 3 minus 5y. Right or not? Then we simplify this one. Now we simplify this one. Now we want to simplify this one. What is the value? Just you see, 3 minus 5y by a plus b, a minus b. What is the value? 3 the square minus 5y the square. What is the value? 3 minus 5y by 3 minus 5y by 3 रो square is equal to 9 plus 5pi रो a minus b रो a square minus b square. So 9 minus 25i square. What is that? 3 minus 5pi whole divided by 9 minus 25 minus 1. What is that? 3 minus 5pi by 9 minus 25. Right or not? So how it is? 3 by 34. 3 by 34 plus minus 5pi by 34. This number is representing the inverse of Z1. Z1, right or not? So Z1 into Z1 inverse, Z1 into Z1 inverse is equal to 1. This is what? Multiplicative inverse of a complex number. So, my dear students, I may cover the properties of a complex number, means addition rule as well as multiplication rule. In addition rule, we are cover the closure property, we are cover the commutative property, we are cover the associative property, we also cover identity property, and we also cover inverse property. In inverse property, in case of multiplication, multiplicative inverse. In case of identity property, is additive identity as well as also multiplicative identity. This is cover the properties of two complex. Conjugate of a complex number. What is conjugative complex number? Suppose I have a Z is a complex number of the form of a plus ib, then Z of conjugate, that means Z bar is equal to a minus ib. That means change of imaginary number. If complex number as a positive ib, in case of a conjugative complex number, negative ib. Because the only change of the imaginary part of a complex number in case of a conjugate. If Z is equal to a plus ib, then Z bar is represent conjugate of a complex number, that is a minus ib. For an example, suppose Z is equal to 3 plus 5pi, the conjugate of Z is equal to 3 minus 5pi. There is no change in real part, only change in the imaginary part of a complex number. If it is positive, in case of conjugate it is negative. If it is negative, then we convert into positive. Just an example, suppose Z is equal to 3 minus 5pi, Z conjugate is equal to 3 plus 5pi. Here we only change the part of positive, this is negative to positive, and here positive to negative. That is a conjugate of a complex number. If Z is a complex number, the conjugate complex number is Z bar. If Z bar is a conjugate number, then Z bar conjugate is equal to Z. That is what? Conjugate of a complex number. Just you see, suppose I have a complex number Z. I have a Z. Suppose I have a rule Z conjugate whole conjugate is equal to Z. Now I justify Z conjugate whole conjugate is equal to Z. How? Just we check. Suppose Z is a complex number a plus ib, and Z conjugate is a complex number a minus ib, then the conjugate of the whole conjugate is equal to a plus ib. Here we justify Z conjugate whole conjugate is equal to Z. What is that? That is known as conjugate a complex number. It is one more rule in case of conjugate of a complex number. For example, suppose I have a Z is equal to 3 plus 0i. Z conjugate is equal to what? 3 minus 0i. Z conjugate whole conjugate is equal to what? 3 plus 0i. That means here we observe that Z bar whole bar is equal to Z. If another more question, what is the conjugate part of 5i? What is the conjugate part of 5i? That means Z first you convert Z bar, Z is equal to, this is purely imaginary number, we convert a complex number Z is equal to 0 plus 5pi. Then z conjugate is equal to what? 0 minus 5pi. Then 0 minus 5pi is the conjugate of z. Is the conjugate of z. That is one more rule in case of conjugate of a complex number. Now again, one more rule again. Suppose I have a complex. Suppose in case of rule 2, z1 plus z2 ro whole conjugate is equal to z1 conjugate plus z2 ro conjugate. Just we prove. Suppose z1 is equal to a plus ib, z2 is equal to c plus id, then z1 ro conjugate is equal to a minus ib, z2 ro conjugate is equal to what? C minus id. So z1 plus z2 is equal to a plus c, real part to real part, plus I into b plus d, real part to real part and imaginary part to imaginary part. That is what? A plus c plus I into b plus d. Just way z1 plus z2 ro whole conjugate is equal to what? A plus c minus of I into b plus d. That means only we change the positive to negative in case of imaginary part. That is what? That is LH side of rule 1. Then RHS side of rule 1. Z1 conjugate what? Z1 no bar is equal to a minus ib, Z2 ro conjugate what? C minus id, Z1 plus Z2 ro conjugate is equal to what? A plus c minus I, b plus d. That is what? Z1 bar plus Z2 bar is equals to Z1 plus Z2 ro whole bar. That is what? That is another rule in case of conjugate of a complex number. So this is conjugate of a complex number. In case of a conjugate of a complex number, we only change the sign part of the imaginary part of a complex number. If it is positive, we convert to negative. If it is negative, convert into positive. That is no change sign part of the real part of a complex number. That is what? Conjugate of a complex